I'm sure that we can all agree with this. There is nothing worse than you are having a conversation with an AI agent and the AI agent keep asking you follow-up questions about things that you've just said seconds before.
Hi, I'm Tom.
Henry.
Marlon.
Doug.
Lucy.
Hi. Oh, those are cool flip-flops. Where'd you get them?
You like those? It's an interesting story. I was over on the North Shore the other day.
Hi, I'm Tom.
Huh? Henry.
Hi.
Marlon.
If this happens, that means that the AI agent wasn't designed to remember things that pertain to a given context or conversation, or more specifically, a thread between the user and the AI agent. In this video, we're going to show you how to actually design this capability using the integration between LangGraph and Redis.
Don't worry, you're not going to suffer any short-term memory loss.
Let's get to it. All right, so let's start our implementation by taking care of the dependencies that we're going to need for this example. The first dependency, and the most obvious one, is going to be the Redis database, right? So in the repository that I'm using here, I've created this Docker compose file that gives you the ability to spin up a Redis database using the 8th version of the Redis database. And then that's the preferable way for you to use this example. Optionally, you can create a database on Redis Cloud, a free one, so you don't have to pay anything to run this example. But for this example, we're going to use Docker and spin up the database locally. So all you have to do is to open up a console and then execute Docker compose up, right? So what this is going to do is basically spin up the Redis database locally. And as you can see here, when you see this message on the log, ready to accept connections TCP, that means that the Redis database is open for business. So that is the go-to for you to continue the example, right? So I'm gonna minimize the console here. The database is up and running. And then the next step is taking care of the dependencies of our Jupyter notebook, right? So I'm going to actually execute this part here while I explain it, but there are 3 dependencies that you need to take care of. The first one is going to be the LangChain OpenAI. We're going to use OpenAI to actually use our LLM for answering the questions. So the integration with LangChain is going to be necessary. Obviously, since we're building an application with LangGraph, we need to install LangGraph. And also, you're going to need LangGraph checkpoint Redis. So what this is the actual integration that Redis provides to the LangGraph framework. And it provides the ability to not only use checkpointers, I'm going to explain checkpointers in a minute, but also the ability to use a database and a vector store. So all of this integration is provided out of the box with this dependency here. So we're going to, in this example, explore the concept of checkpointers, which is the ability to store information within a single thread or a single context, right? So since we're going to use OpenAI, you're going to need to create a OpenAI API key beforehand, right? So in this case here, I'm reading my OpenAI API key as a environment variable. So I encourage you to do this beforehand. I'm going to put here in the description of this video the link about how you can create your own API key from OpenAI. So you can settle with this. And then the next step is going to be the graph implementation. So as you may know, LangGraph is all about creating graphs, right? So the concept of graphs is very powerful because it provides you the building blocks of the states and the execution of each states and the connected graphs between them. So every time you move forward between one step to another, that is a checkpoint, right? That provides a state, and the state needs to be saved somewhere. That's where the concept of checkpointers is going to be useful, right? So our code starts with the instantiation of our model. So we're going to create a model that is basically a chat with OpenAI. So this is going to be the LLM that we're going to use for this example. We're going to also use a tool that we've created here manually using Python. And this is basically this function called getWeather. This is a very simplistic function that basically, given a location provided as a parameter, we're going to provide the responses. If it's New York, we're going to say that it's always cloudy, and if it's San Francisco, it's going to be always sunny, right? We know that this is not always true, but bear with me here in this example, right? So we're going to provide the stools as an array here, as you can see, and then we're going to actually start the implementation of our integration with Redis, right? So the Redis URI uses the syntax that you can connect with your Redis database. Since we're using a Redis database running locally here, This is the syntax that you need to use, right? And then the building block that you're going to use for this is going to be called Redis Saver, right? So Redis Saver, as you can see here, is part of the Checkpoint Redis LangGraph integration. So this is the SDK that we're going to use. And then from the connection string, which is the Redis URI, we're going to instantiate a checkpointer, right? So checkpointers, just for you to know, is a concept that is kind of a native for LangGraph. Like LangGraph needs checkpointers, as I mentioned before, to handle the transitions between each states of the graph, right? So this has nothing to do conceptually with Redis. What we're going to do here is to replace the built-in checkpointers with a custom one, right? Provided by Redis, right? And then we're going to use this checkpoint. As you can see here, we are associating this checkpointers with this variable here called checkpointer. And when we create a graph here below, we're going to provide a model, provide the array of tools. There's only one, but it could be more than one. And as a checkpointer, we're going to use this checkpointer that points to Redis, right? So let me execute this code beforehand, and then let's see how this graph looks like. So as you can see here, this graph is very simplistic. So that's start, there's the agent. The agent's going to be like may provide multiple invocation to the tools, and then once it responds, it goes to the end, right? So that's a very simplistic graph, but it's going to be very useful for us to prove the point of the communication with Redis, right? As a heads up, there is this invocation call once we create a checkpointer from Redis to this function called setup, right? So this is very important. Never forget to actually execute this part here, because behind the scenes, what this does is to create the required indices on Redis for you to materialize all the data that needs to be saved. If we actually inspect that the database right now using Redis Insight, we're going to see some keys. Actually, I take that back. There will be no keys stored because there's no data, but the indices, yeah, that's the one that I would like to showcase. The indices will be created already. This is the result of that invocation setup, right? So it's created checkpoint writes, checkpoints, and checkpoints blobs, right? So there's no data yet because there's no execution of the graph at this point, right? So let's move forward and then continue the execution of our example. And in this example, we're going to basically do this, right? We're going to instantiate a new thread. You can think about a thread as a conversation between one user and the LLM, right? So that's a thread, right? That's a single occurrence of a conversation. And that thread is going to be named. So this is going to be thread number 1, right? So this is important because the concept of thread ID, that's what is going to uniquely identify that conversation or thread for LangGraph. And more importantly, information is going to be saved on Redis. So that's how Redis is going to be able to, oh, okay, it's part of the same conversation. So here is the set of information that is stored along with that conversation, right? So, and then we're going to say, what's the weather on New York City, right? So that's a very simple question. And then behind the scenes, what's going to happen is that the LLM is going to use the tools that we provided to the graph, and it's going to respond, yeah, it's always cloudy, right? But subsequently, we're going to also know what's snowing for. But mind that in this question here, we're not mentioning explicitly the word New York City or New York or NY as an acronym. So that's how we're going to force the LLM, not the LLM, actually LangGraph, to remember this piece of information that at this point is going to be stored on Redis. But before I actually execute this code, let me explain only what this print string function does. This is a utility function that I've created here for demonstration purposes, so we can actually navigate in the results that comes from the string of the graph, right? So I'm going to actually define this function, and then let's start executing our first interaction with the LLM. So as I mentioned before, the question is, what is the weather on New York City? This is for thread 1, right? So as you can see here on the follow-up log, there's all the questions and the invocation of the tools, and then the name of the function that proves that the graph was able to identify, given the context of the usage, what tools to provide to fulfill that question, right? And then it's going to answer that it might be cloudy in New York City. So that that is the response that was provided by the tools that was leveraged by LangGraph. Before we continue with our verification if the LangGraph is actually being able to remember, let's take a look on Redis to see if there are any keys stored right now. So I'm going to refresh the number of keys, and as you can see now, we have a couple keys already stored. So if you see here on checkpoint, you're going to see a couple of pieces of information already stored. So that is my original question here. And as you can see, the concept of thread ID is a very vital piece of information. That's how Redis and ultimately LangGraph is able to kind of locate the information that is associated with the current conversation, or for the sake of the argument, the conversation that is being handled right now. Because remember, LLM applications are inherently stateless, right? So they're not able to maintain state. So that's why it's important for you to actually provide a backend database such as Redis that is capable of storing information in a fast and scalable way, right? So that's one important things about the architecture. So now let's prove the point of remembering. So we're gonna ask what is known for. So hopefully it's going to be able to detect that we're talking about New York and then put some information that is only relevant to New York. So here's the answer, right? So yeah, New York, so it was able to remember that we're talking about New York, is known for education and research. So there's a prestigious institutions like Columbia University and New York University. So to prove that we're talking about New York, right? Because I know for sure that those universities are not available in San Francisco. The iconic skyline, so known for its impressive skyline feature and skyscrapers. The public transportation, the subways that we all know about New York, and sports, right? So there's just a few highlights of makes New York City, right, unique and a vibrant place. So as you can see here, all of this was able because we've stored all the transitions and the state of this current conversation or thread, right, in a backend store, which is in this case is Redis. And this was possible given the integration that Redis provides with LangGraph through this building block called checkpoints, right? So the TLDR is that every time you need to store the state between a LangGraph execution and a backend store like Redis, you need to instantiate a checkpointer, and this checkpointer needs to be created with the SDK from LangGraph, which is provided here for you out of the box with this building block called Redis Saver. How's about that? Was so easy to make sure that your AI agent remember things given the context of a given conversation using this built-in integration between Redis and LangGraph. I hope you have enjoyed this approach, and if you are interested in seeing more scenarios of how to handle memory within the context of LangGraph applications, I will put here on the description of this video a link of a GitHub repository that provides several examples of how you can further explore this integration between Redis and LangGraph. Also, if you like this video, please don't forget to give it a like, and then if the context of this channel is also important to you and provides you useful information, make sure to subscribe so you never miss the next video that we're going to publish. I hope you have a great day and see you next time.